begin with the last remaining notes of section 2.5. In this section, we're talking about limits, infinite limits. And again, remember, we have a section coming up in chapter 4, section 4.5, I believe, that also talks about infinite limits, but it's of a different nature. For this one, we're talking about, well, I'll ask you the question. Are we talking about the inputs going to infinity or the outputs going to infinity? And obviously, since we've got the example on the screen, hopefully everyone is getting in the thinking mood. We're obviously not talking about the inputs going to infinity, so it must be then the outputs. Okay. Which it means that we're creating, graphically, we're creating what? If the outputs go to infinity, graphically, for some of these, we are creating what? Well, I would have to say for all of these, if the outputs go to infinity. What's that graphical phenomena that happens? Say it again. Yeah, an asymptote, vertical asymptote. Okay, so we have something like this, and the graph is going to go either here, it can go down here, and so forth. Okay. Well, let's see now. Another piece of review is that when we have a limit, the output here is going to -1/2, and the little plus means what? Yeah, from the greater. Please refrain from saying from the positive side. We're going to negative infinity, so that does not mean that we're going to be looking at only positive input values. Instead, we're going to say that we're coming to -1/2 from the greater than -1/2 side. So if you think about that as positive, you may get tripped up, especially when you're on a test or a quiz, and that the stress is there, and you all of a sudden begin to doubt yourself. You may make a mistake. So start now by thinking of this as greater than -1/2 side. Okay, so we also know from our work with limits that if we can just make a substitution, our job is done. But what happens when we substitute -1/2 into this? Is there a problem? Let's see, -1/2 squared is 1/4. 4 times 1/4 is 1. 4 times -1/2 is -2, and then take the opposite of that, so that would be +2. We have to 1 plus 2 now, and then of course this would be a zero denominator, so we cannot do that. What is one of our algebraic processes that you practiced a whole lot back in Algebra 1? Yeah, say it again, Kaylee. Factoring. Okay, so we're going to factor this. What must I write first before I show the factoring of these two trinomials? Yeah, remember, and this, we haven't had a quiz on this yet, and I can just guarantee you that we're going to have some students forget to write this, and it is not going to be correct. It will not be correct. You will not get full credit for the problem if you forget to write the direction. Again, it's the same thing as saying if you have the square root of 25 and the next step you write is just 25. It's not correct because you've dropped the idea, the function that we're supposed to be working with. Okay, so now we just have to get our factoring hats on and do the best we can on factoring. This is not an Algebra 1 how to factor class, and so that's why your inspires can be very important to you. I would expect you to be able to do the factoring in your head. It would be nice if we did that, but you know, you're going to come up to the quiz and the test, you're going to be stressed, you're going to need as much help as you can get. Do you know how to use your inspires to do factoring if that's the one piece that you're kind of stumbling on? Do we need to go over that? How to factor. Okay, so if I even see one yes, I'm going to do this. Okay, so we're going to take this, let's take our inspires, and let's go to a new document, and let's look at how to factor. Calculator, page, menu, algebra, and there it is, factor. Again, I expect you to be able to do this in your head. I don't expect you to have to do this for everything. But if you get stuck and you need to do this, by all means, we need to know how we can use the tools to help us out here. So we're going to put that trinomial in here. So we have, let's see, x squared plus x minus 1. Now, you don't have to do this for everything, but it's a good rule of thumb because some of these things you do have to do it on. Just do it for all. Find your comma and x. Factor with respect to x and press enter. Okay, again, I'm sure you could have done this in your heads without any prompting, but if you need that, if that's the one thing that you're just not thinking straight on, use the tools. It's like the days you don't feel like walking, you grab the keys for the car and you don't walk a mile, you drive a mile. Okay, what about 4x squared minus 4x minus 3? I'll give you a minute to think about that. Do we agree on the factors? Okay. Now we had a theorem back in, section, must have been 2.3 maybe, that talked about limits that agree at everywhere except at one point. And this would be one of those. This limit, this function, is going to agree everywhere except at what value? Because of the fan, I'm not hearing anything but a mumbling. Help me out here. Well, you know what? If you're like me today, it's a low energy day. I'm just going to ask you this question. Because we have actually two functions, I'll make sure we understand that. These functions agree at every point except okay. So give me your answer there, please. Again, the question is, what are the two functions we're talking about here? Well, one of them is the original one, right? Okay, good. That's good. What's the other one? Pardon?
Factor function.
Yeah, and not including the common factor? Okay, yeah, absolutely. So it'd be this one right here. So it's those two functions. Do we need to have you resubmit your answers? Did anyone not understand that to begin with? If so, speak up. Just give me a nod, and I'll have you give your answer again. Okay, I see no nods. So let's look at these. Let's see what responses you have. Everything except 1.5, negative 1/2, negative 1/2, negative 1/2, negative 1/2. 1, I'm not understanding this. 1 at x equaling, oh, that there's 1 point, and that's at x equaling negative 1/2, okay. Negative 1/2. Negative 1, I would disagree with. This is your new function now that we've talked about that. And so I'm asking at what point, and these would not be points, these would be expressions, but you're on the right track. Okay. Negative 1 1/2, and I don't think that would be correct on that one. Okay, we'll just save that to the portfolio and go on. Okay, so everything, these two functions are going to be agreeing everywhere except at one point. What might happen at this point? Could be a hole, okay? Or it could be as we said before, if it's the output's going to infinity, then it could be that we would have an asymptote, but I really don't think that's going to happen at this point. But let's see what does happen. We're going to approach negative 1/2 from the greater than 1/2 side. Can I use direct substitution now? Yes. It doesn't interfere with the value of our denominator. Denominator won't be 0. Must I write this information? If I do, is it okay? Let me ask you this. Is it okay if I continue writing the direction there? No. So what do you think? Is this if I use direct substitution, is this acceptable? No, absolutely not. Okay. So we're going to start this step over again. And so we would say that it's 3 times negative 1/2. Now you say, but I'm approaching it. Okay, well when we approach it, it means that we say the question or have the statement, what if? What if I could use it? If I could use it, what would it be like? And so we're going to put that in. And your answer is 5/8 or negative 5/8? Positive 5/8. Now, I really like this this next piece, and you're going to have to be aware of it. I haven't written the quiz yet, but I probably will come up. If I ask you to give me a graphical representation, draw a graph that shows me what you understand of this problem, what would you do? I'm going to give you a couple of minutes to do that. Akeem? Do you want now? Before this step? This one? Again, once I use direct substitution, I have taken the limit. Okay? So it would be completely incorrect to write that. Okay, graphical representation, something that shows me you understand this beyond just moving these numbers and letters around. What would you want to show me on a graph? Good. What function would you give me? And what of the original? This is the original problem. Everything? Just the function. Okay, so let's put that function in. Now, what on this graph would you want to show? This is your problem again. Excuse me? Okay, is the vertical asymptote the limit of the function? No. Okay, so we'd want to be careful about doing the vertical asymptote. Okay.